So hey everyone, welcome back to the channel. In this video we will be solving the problem paths from root with a specified sum. So let's read the problem statement out. So we are given a binary tree and a sum s. Print all the paths starting from root that sums up to the given sum. Path may not end on a leaf node. Okay. So there are three variations of this problem and this is one of them. So we are given a sum equal to 8 and our tree looks like this. Now, the path which sums up to 8 is 1, 3, and 4. Now, one thing you should remember like the path should start from the root node, but it may or may not end at the leaf node. So, this is going to our output. Similarly, for this, there are two paths basically 10 and 28, and the other path is 10, 13, and 15. So, we need to print both of them. So I hope you have understood the problem and let's discuss this problem in more detail. So for this test case, our sum was 8. Now we need to keep two things in mind. Basically, the tree can start from the root node and it may or may not end at the leaf node. Now, in order to do this problem, we will be using recursion as we do with other tree problems. Now, we will be taking a current sum which will basically store how much sum we have made till now. So initially it is going to be 0 and we will be taking a current path or current vector. Basically it will be storing the nodes which we have taken and also a answer vector which will be a type of vector of int. Java people can use array list here. Okay, so what we will do, we will pass this into our function, basically the recursive function, and initially our current sum is going to be 0. So let's take this and we will call the recursion on the left tree first. So current sum here will be 1. We will go on to the left tree and we will add this to our current sum and we will store 1 into our current vector. And when we go to this, our current sum will increase to 21 and we will push 20 into our current vector. Okay, now since at this point of time this has no left child, so we will return from here, and now our current sum is going to be 21, right? But since we are not able to make this sum as 8, we will remove this 20 from our current sum when we return from this node. So current sum will remain as 1 and we will pop this back from the current vector. Now we go on to the right child. So we go on to 3 and our current sum will now be 4. Okay. So 1 plus 3 is going to be 4 and our current vector will now be 1 comma 3. Okay. Now we will call the recursion first on the left subtree. So we go to 4 and we add up 4 into our current sum and our current sum will be 8. And we will push this into our current vector. Now at this point of time our current sum is equal to the required sum. So we will push this back into our answer vector. Now we go on to the left tree. We add up 6 into our current sum and our current sum will be 14. But since this is not equal to our required sum, we will return. And while returning, we will subtract this from our current sum. So our current sum will be 8 and this will return. Now similarly, before returning from here, we will go on to the right child. So 8 plus 7 is going to be 15. But since this is not required sum, we will return and this will return. Now we go on to the right child. We add this up to our current sum. So here the current sum is going to be 4. 4 plus 15 is going to be 19. We go on to the left child. Since this doesn't make our required sum, so we return. Similarly, we go on to the right child, and since 19 plus 9 is going to be 28, which is not equal to our required sum, which is 8. So we will again return, and this will return, and this will return. So finally, our answer vector will be containing this, and this we need to return. So I hope you have understood the problem. Now let's discuss the recursive call. So let's say our recursive function looks something like this. It will be accepting a root node and the current sum, the required sum, the current vector, as well as the answer vector. And the base case, if our root is going to be null, we simply return, right? Now the other step is basically whatever the node we are taking, we will be adding that up to our current sum. So current sum will be incremented by root arrow key, and we will push this into our current vector, right? Because we are taking this node into consideration. Now similarly, at this point of time, we can check if our current sum is equal to the required sum or not. If that is the case, we can push this into our answer vector. So answer dot pushback current, right? And now we will call the recursion on the left subtree. So solve root arrow left, other parameters will remain same, right? And similarly solve for root arrow right. And while returning, when we are finished with our execution, what we need to do, since we have added this to our root arrow key, so current sum will be decremented by root arrow key. Similarly, this should be popped out of our current vector. So current dot pop underscore back, right? Now why we are doing this step? Because these we are passing as reference, right? So this too will be passed as a reference. So I hope you have understood the algorithm. Let's discuss the code. Now first of all, we have taken an answer vector, which will be a type vector of int, and vector of int current, that will be storing the current path. Our current sum initially will be going to be 0, and solve method, it accepts root, sum, current sum, answer and current path. Okay. And finally, when we are done with this, we will be returning our answer, because at this point of time our answer vector will be storing all the paths. So first of all, if our root is going to be null, we will simply return, because we can't do any operation there, right? Now whenever we visit a node, we will push that into our current vector, and our current sum will be incremented by root arrow key. Now at this point of time, if our current sum is equal to sum, means we have got a path, and we will push that into our answer vector, and we will call the recursion for the left subtree, we will call the recursion for the right subtree, and these two are backtracking steps. So here, since we have taken this node into consideration, so we will pop that out of our current vector, and our current sum will be decremented by root arrow key. So I hope you have understood the problem. If you have any doubts, write it down in the comments. Like this video if you have understood, share among your friends, and don't forget to subscribe the channel. Thanks for watching, guys.